That's what your test last week was on. Today's the 6th. There you go. Today's the 6th. There's the timer, so go ahead and finish up whichever one you're on. There you go, underneath. On these warm-ups, you do get to use your notes. Yes. Well, just warm-ups. They're not quizzes or tests.
I've been using my notes this whole time. It's like minty.
Hey, do I have everybody's?
Yeah.
Oh, Kaden? I need your.
Oh, sorry.
Okay, so the small paper that you have is that we're going to be doing first. Phones should not be up or out, and everybody should have a calculator. So if you didn't grab a calculator on your way in, go grab a calculator. We're going to talk about how reminding you how to do stuff on the calculator.
What? My calculator messed up, man. I'm gonna clear it. 1, 2, 3.
We have got this is our last major unit. Okay. So this week and next week we're going to be doing unit 10. The next week you've got the English STAR test, the mock algebra STAR test, and then the week after that we have a short mini unit, and that's the end of our stuff, and then we'll be doing STAR review in class after that. So
What's a mock?
just like you did a mock STAR, well, for the English EOCs, it's a practice STAR test, so we can see where you're at, see where your weaknesses still are, so we can work on helping you bring those weaknesses up so you can pass before the real one. So, okay, so on your calculator, how do you get to a graphing screen? There is. If you're on the home screen, you got this right here. It's a picture of a graph. You've got this picture of a graph right here. You've got this right here. It says the word graph right there. Okay. This right here is a mouse, so you can mouse around or arrow down. You can just type the letter B. If you hit the letter B, that's the shortcut key to get you to graph. Okay, the flying calculator, if you hit it once, okay, most of the time it should take you to the calculator page. If you hit it again, it will flip you back and forth between a graph and a calculator. That's why the scratch pad or the flying calculator is easier to use, because you can flip real easily back and forth between the two. If you go here to this graph, it opens up a document screen, which is fine, but it doesn't take you easily to back and forth to a calculator. So using what's called the scratch pad is quicker access back and forth between the two things that you need to use. Okay? So my graph doesn't have where I need to type something in. So how do I get it to pop up what I need to type in so I can type something into graph? Okay, I can click on the square. If I just click it once, nothing happens. If I click it twice using this little mouse thing right here in the blank area, it will open it up for you. The other thing you can do is hit the tab button. This tab button will open it up for you as well. Do not type the equals 0. You do not want the equals 0, and you don't want to erase anything that's already there for you. So type in the problem, 2x squared plus 5x minus 3. When you get it typed in, hit enter. If you get a line, you either forgot the square on your x, or you forgot your x's altogether. Or in one class, I put a times instead of a plus for whatever reason in there. So if you do not get, what shape should you get if you have a power of 2 on your problem? What shape should you get?
A U.
A U. You should get a U shape. We call that a parabola, right? But it should be U shaped. So if you do not get a U shape, okay, or in some cases you can, you might get a line coming down. Oops, I didn't mean to drag it. Get a line coming down, and then you have another line coming up over here. That just means you don't see the vertex, but it's there. I mean, it's still a U shape if you see two lines on the edges usually. You just might need to zoom out. Okay, but I got to retype it because I clicked something. So what was it? 2x squared plus 5x minus 3. Okay, does everybody get something like that?
Yeah.
Okay. So on your first box right there, okay, we're going to sketch that graph. There's no tick marks or numbers or whatever on here, so we're just making a rough draft of it. The parabola, okay, was kind of off-centered. It didn't go where that the U went right over the axis, right? It was a little off-centered. So yours should also be off-centered. Does that make sense? All right, something like that. On the paper today, one of the vocabulary words, and on your vocabulary to remember, talked about the axis of symmetry. Whoops. The axis of symmetry goes through that vertex point. So the axis of symmetry is that dotted line that tells you where your vertex is, and then it should be a mirror image on both sides. This is a rough draft, so mine doesn't look like a mirror image on both sides, but it gives you the idea of what I'm talking about. Okay, so where are the solutions? What do we mean when we say solutions?
I can answer you, but I'm.
The solutions are the points that what? On the x-axis specifically. So they're your x-intercepts. So your solutions are the x-intercepts, guys. Okay. Okay, your x-intercepts equal your solutions. They're your same thing. Okay, other words for that are roots. Okay, roots, x-intercepts, solutions, and zeros. Okay, all of those words are talking about the same thing. They're all talking about, okay, that's not a dot on the line, that's just my bullet point. Okay, those are all talking about the same thing. So when my question asks me the number of real solutions, it's just asking me how many real solutions do I have for this problem?
2.
2. I have 2 solutions for this problem. It doesn't want to know what they are, it just wants to know how many that you should expect. If you were having to solve this, how many would you need to figure out to have a correct answer? You would need 2 of them.
Is that always the truth? It's always going to be 2?
Well, we're going to see that here in just a second.
Oh.
Okay. So now, do this next problem. Graph it in your graphing calculator as well. Okay. To erase this one, okay, the easiest way is to click on the graph itself. If you click on the graph itself and hit the delete button, it deletes the whole thing. Okay. If you don't do that and you tab and you open it back up, it may start you on like F2 of X, which is fine. Arrow up and erase it, backspace through it. Okay. So negative 4 x squared plus 12x minus 9.
She has like a blue tab, gray and blue on the corner. How does she delete that?
Hit Control T. Is it a table that's up?
It's the table popped up.
Yeah.
Oh.
So if you do not get something like this, then double check that you typed it in right. I think this is the one where I accidentally hit the times instead of the plus sign right there. So then it didn't look right. And so if it doesn't look like this, then double check and make sure you typed it in correctly. If it's not upside down, you probably forgot the minus. Well, you had to have forgotten the minus right there in front of your A, because if your A is negative, it's an upside down parabola.
We don't have the equals 0.
Don't put the equals 0 part in there. No. So when you graph it on your notes, okay, it's going to be upside down and it's going to be a little bit over touching your x-axis. So when I graph it, that's going to look something like this. Okay. How many solutions is this one going to have? 1. Right there at the vertex, actually. Okay, so it has 1 solution. Okay, and that solution also happens to be the vertex. Okay, so that only happens if there's 1 solution. Okay, where that it is also the vertex.
Is it always like that if it's a negative? It'll always be 1 solution as the vertex?
No, not necessarily. If the A is negative, no. The negative A just tells you it's upside down.
Oh, okay.
So now graph this third one on your graph. I'm going to let you guys do that one. See how you do. See if you can tell me what it looks like when you're done.
It's a U, but it doesn't, it's on the y-axis as well.
Okay.
Go.
So it goes up. Okay. And it doesn't actually ever touch the x-axis. So how many solutions if it doesn't cross the x-axis? 0. Okay. So a problem like this, okay, we would say has no solutions. I'm going to go back over here and show you that the axis of symmetry that we talked about before goes right through that vertex. That's your solution. Over here, your axis of symmetry. All right, something like that. Okay, so when we solve a quadratic equation, we can get 0, 1, or 2 real solutions. And here's another little tidbit of information that you won't run into in Algebra 1, but you will in the future, okay, that the most number of solutions you can have is based on the highest power in your problem. So notice my highest power in this problem is 2. So what's the most solutions I can have? 2. In a linear problem, right, in a linear equation, what's the highest power for a linear equation? A linear equation is just like x plus 7 or 3x plus 7 or whatever. So what's the highest power on my variables for a linear equation? 1. So how many solutions can a linear equation have at most? 1. Okay. So if my power was a 4, what's the most that I could have? 4. Okay. So we haven't looked at the quadratic formula yet. We will next week. So I'm just going to give you this part that's underneath the radical. Okay. It is b squared minus 4ac. b squared minus 4ac. Okay. We call that the discriminant. Okay. All that does is tell you how many real solutions you will get if you're solving it. Okay. This can be a shortcut. Versus graphing it, it can be a shortcut because if you substitute your equation into here or your information into the discriminant, okay, this equation here, then if you get what tells you that there's no solution, then you don't have to worry about solving it. You don't have to work it out anymore. You already know that there's not going to be a solution, then you can answer no solution. Okay? When you use that and you get that there's only one solution, that automatically has to be your vertex. So there's not a lot of solving either other than figuring out your vertex, and that's easy. It's when there's two solutions. I don't know what happened to my screen. I clicked something. When there's two solutions is when that you have to take more steps and you actually have to solve for both of them. Okay, so this can be a shortcut for both of these types of problems. So let me rewrite the problems here. So we've got 2x squared plus 5x minus 3, negative 4x squared plus 12x minus 9, and 3x squared plus x plus 2. Okay, what is my a for this very first one? Make it bigger so you can see it. What's my a going to be? 2. Okay. So a is always paired with the x squared. Remember, it's a x squared plus bx plus c. So a, b, and c are just the numbers, and they have to be paired with the x squared or with the b or with nothing. So the 2 is paired with the x squared, so that means it's my a. The b is going to be what? 5. And my c? Negative 3. So now I'm going to use my formula here that I gave you, my discriminant, and I'm going to substitute those in for it. So I've got 5 squared minus 4 times 2 times negative 3. This is a minus when you put it in your calculator. Just put it in your calculator just like that. Always, if you raise something to the power of something and you plugged it in, put it in parentheses to that power to keep from having a mistake. Go ahead, you got one? 49. If you did not get 49, earlier today in one class we got the number 1. So if you got the number 1, you probably forgot your minus 3 right here, your negative 3. Okay.
Are those problems being able to do on your head with a calculator? Or there's some?
In some well, okay, for instance here, I know that anything squared is going to give me a positive number. Okay, and I know that this negative times this negative is also going to give me a positive number. So if I'm adding two numbers together, am I going to get a negative? No, it's going to be a bigger positive, right?
Right.
So if the discriminant is positive, that's really all I need to know. I don't need to know the number. I just need to know if it's positive. If it's positive, that means I'm going to have 2 real solutions. Okay, because we graphed it up at the top so we could see that it had 2 real solutions, right? So if the discriminant is positive, you should have 2 solutions. Okay, so now if we do this next one, what is my A for the second one?
-4.
-4, 12, -9. When I substitute in, I'm going to have 12 squared minus 4 times -4 times -9. I already told you when you square something, you always get what kind of a number?
Positive.
Positive. And if I've got 3 negatives over here, I'm going to get a negative number. So I actually do need to know this number because I need to know, am I going to end up with a negative? Is it still going to be positive? Is it going to be 0?
Zero.
It's going to be 0. Ah. Okay. So I actually get 0 because this is 144 minus 144 when I work it all out, which equals 0. So if the discriminant equals 0, how many solutions did we get on that graph?
0.
Nope.
1.
We got 1 solution. Okay, that 1 solution happens to be the vertex. So if you figure out that your discriminant is 0, then that means your 1 solution has to be the vertex.
That makes sense.
So what do you think is going to happen in this one? Any guesses?
She wanted to know how you got the 144 from the 4 times 4 times 9, right? That's where you got the 144?
Mm-hmm.
Yeah, those are for those.
So any guesses on what type of discriminant we're going to have on this one? My A is 3. My B is what? Not X, it's 1. It has to be a number. And my C is 2. So I've got 1 squared minus 4 times 3 times 2.
How did you get the minus 4?
Yeah.
Because it's part of my equation.
Oh.
Okay. So, yeah. So that minus 4 is part of the equation there. And everything I substituted in, I put in parentheses to help me remember that that's what I substituted in. So you would get negative 23. Because you do get 1 squared is 1, and then minus 24 is negative 23. So if I get a negative discriminant, what does that mean? How many solutions do I have? 0. I have 0 real solutions. So I would know in this case that I could already answer no solutions. I don't have to do any more work because I already determined there's not going to be any solutions. So this next note page, okay, there's what you need to write at the top. Okay, we've already talked about this a little bit, that quadratic roots, okay, roots and zeros, solutions, x-intercepts are all the same thing. They're all talking about the same thing. They're all talking about the points at which the parabola intersects the x-axis. So I'm going back and reviewing a little bit on how to do stuff on the calculator, because as you get closer to the star, you really need to know how to utilize your calculator, because that could make it or break it for you on a math test, period, but especially on the algebra one, right? Before we put this one on our calculator, does anybody remember what AOS stands for? Let me give a hint here. Axis of symmetry. We talked about it on the first page, right? Okay, the axis of symmetry. If you need to fill out a table for a quadratic equation, your first step, okay, to know what you need to fill in your table, is to figure out what the axis of symmetry is. Okay? To do that, we're going to use the formula negative b over 2a. Negative b over 2a. So what is my b in this equation?
-10.
-10. Okay, what's my a?
1.
1. So I've got -10. Okay, I have to use the double negative because there's a negative in my equation. So I have to have that first negative out there. And then -10 is what I substituted in as my b, divided by 2 times 1, which is my a. So what is a -10? +10. Yep. And what is 2 times 1? 2. So 10 divided by 2 is? So right, we're dividing by 2, we're halving it. Okay, all this tells us, okay, is that we need our x to be 5 right in the middle of my table. So right in the middle of my table, I want my axis of symmetry. This will be my vertex point when I figure out what my y is. Because it's my vertex point, I know that everything is going to be a mirror image around that point. So I'm going to count down on the top half of my table. So from 5, I went 4, 3, 2. And on the bottom half of my table, I went 6, 7, 8. So now, graph this equation on your graph in your calculator. So we've got x squared minus 10x plus 16. How do I get a table? How do I get the table to pop up so I can fill in my table?
Control T.
Control T. Okay, Control T. Okay. So now I have my table. Here are my x values. What is the first x value that I need to fill in the table on my notes?
5. 0, 1.
I could go down to 5 and start there, but what's the first number at the top of my table on my notes? 2. So when x equals 2, what is my y?
0.
0. So put a 0 for the y. At 3, what is it?
-5.
-5. Okay, so finish filling out your table using what you graphed there.
How How do you get the table again?
Control T. After you graph it, then hit Control T. So notice, okay, notice that these are mirror images, right? Because we did it around our axis of symmetry. So once you have the first 3 or 4, because you need your vertex number, it should be the same on the other side, right? Okay. What are my solutions? 2 and 8. Wherever my y equals 0, those are my solutions. So x equals 2, 8. So these are my solutions. So if you graphed it, okay, then you would have intersections at 2 and 8. And your vertex is down here at 5, -9. And because it's mirrored, okay, your dots would look something like that. Okay. I want to just talk about this next one really, really quick, because if my formula for my axis of symmetry is -b/2a, what is my b in this problem?
Your 9.
Nope.
Your what?
Nope. Do I have a number paired with a regular x?
No.
No, right? I've got -1x squared, so that's my a, right? But I don't have anything paired with an x, because that's my b. Then I've got 9, so that's my c. If I don't have anything, what number do we use to represent nothing?
0.
Nothing is 0, right? If there's nothing there, it's 0. So if I have -0 divided by 2 times -1, well, 0 divided by anything is what?
0.
0. Okay? So 0 goes right here in the middle. And then I'm going to count down. Okay? -1, -2, -3. 1, 2, 3. And just really quick, this would be 9, and this would, my zeros would be here on the end. Okay.
Zeros always be on the end.
Not always. If you did that third one, that number 6 one, it's a skinnier graph because the A is not a 1. These other two, the A was a 1, so they were like that. But for this one, I just wanted to point out that you can shorthand it with a plus or -3 like this. So you will see on your homework, okay, that some of the solutions may say plus or minus, and it's because that's what your zeros are. They are the same number, they're just positive or negative. So this is in Go Formative. This is the last week of the grading period, so everything is due no later than Friday. Okay? The first side is just determining how many solutions you're not solving, and the back side is solving it by graphing. You don't have to graph or anything on it. Okay. Yes, ma'am.
Are you going to open up the
I can, but I'm going to close it like at 5 o'clock today because I need to get those grades updated for people that have got them turned in.
Okay, that's fine.
Okay.